those features are available for all of these different public data sets. Now, as far as other things, you've got a geospatial layer also tab under here, and this is where you can actually go ahead and upload your own data if you would like to. If you're logged in, it'll save that data. I'm currently not logged into eRAMS. I'm just on the public version, the public non-login version of the flow analysis tool. And so if I upload any data, this just gets deleted once I close my browser and log out of that. It doesn't persist. But if I were to log into eRAMS under my account and then set up a flow analysis project and upload that layer, it'll stay there. Any questions on that stuff? Okay, so I'm going to move over into the actual flow analysis tool itself, which is basically, it starts off with picking what sort of station you want to look at. So there's a number of different ways that you can search. Just like Google Maps, you can zoom to locations. So I'm going to zoom into Fort Collins just because most of us are familiar with that area a little bit. You can search by just keyword, like if I wanted to examine just flow analysis gauging sites on the Poudre River, what it's going to do is it's going to search the entire combined database of USGS monitoring sites, STORET monitoring sites, CDWR monitoring sites, and then it'll put them all on this map. And you can see that it's pretty much just concentrated to where the Poudre River is in Colorado. And the different colored pins are the different databases. So the red ones here are STORET monitoring sites, the green ones are CDWR, and the blue ones are USGS. When you find a site that you're interested in, you can click on it and you'll get this nice little summary of who it is, where they're at, where's it actually at on the river, and a little data summary of what sort of data was available a couple years back when we did a full summary of these different databases. But the cool part of the flow analysis tool is actually right here in the flow analysis model part, is the actual heart and soul of the tool itself is the analyses. So again, it starts off with that nice little summary of all the different station attributes in that data summary, but you can actually start digging into analyzing the data that's available for this site. One thing that we've added on top of this, I see that we got a quick question. So one thing that we've added on top of this is if you want to analyze not only USGS data, you can analyze uploaded data. You can analyze only your uploaded data or merge it in with the available USGS data. And you get to that link here on the Station tab under this Upload Your Own Data. And this first little section here describes how you need to format it. The basic format is a CSV file with a date and a value. And then a header that says date and then what kind of water quality test it is. So if it's a flow test, you got to signify it with flow. If it's one of the USGS nutrient tests, you got to signify it with this 5-digit code that USGS uses. So 00600 is their total nitrogen code. That'd be how you'd upload your CSV file to use it in this particular tool. And it's a straight once you got that file formatted, you just pick it out on your computer and upload it. Did I clarify that okay? Cool. Thank you. But all of the analyses are set up to analyze just uploaded data or analyze the merge or just the USGS data itself. On this data tab, the data tab is more of just like a statistical summary of what's available for a given site. It has a whole bunch of different advanced options that you can go in and specify seasonal statistics for a summary CSV file you can get. You can get some extra different inputs for graphing options. You can do period analysis. So say you're examining a stream gauge that had a dam put in upstream of it. You could examine the record before the dam and after the dam and during construction as 3 different periods and see what sort of statistical differences there are. Once you run the analysis, you're going to get a series of summary graphs and summary statistics. Everyone knows what the standard time series looks like. And you got a little statistic summary here on the average flow at this particular site is 157 CFS. You got a nice little envelope plot that plots all the different years on top of each other so that you can see the average. That's this black line. That's the average flow over the entire period of record versus the median versus every single year plotted as a gray line, and last year or this year as that light blue line. You can also do pixel-based plots, which are some of the more advanced forms of analyzing time series data. We also have just monthly averages, histogram plots, and CDF curves. And like I said, one of the things that you can get out of this one is a summary CSV file that includes all sorts of statistics about this flow analysis tool. So for a given period of record, for the entire period of record, you can get how many data points there are, the maximum, the minimum, the 1-day maximum average, the 3-day maximum average, the 7-day minimum, all sorts of stuff. This is all based on Nature Conservancy indicators of hydrologic alteration. So there's tons and tons of different statistics in this file. And then not only does it summarize it for the entire period of record, it summarizes it per year as well. So you can compare 1979's data versus 2015's data all the way over here if you wanted to. But we don't need to go that deep into it. One of the options that all of these tools have is you have those static graphs. You can also choose to use a more dynamic graph, and this allows a little more web interaction that you can actually start playing with the data and seeing a little bit better. With some of those, with those big pixel plots, with those time series, you can actually zoom into a smaller scale resolution on the dynamic graph and save it or upload it or download it or view it. It does take a little bit longer to load those graphs just because all that data is getting pulled into the web browser itself, so there's a loading slowdown there. As far as the biological flow stats, those are not currently included in that CSV file. Those biological flow stat summaries are available in a low flow analysis that is inside of the CDPHE tools. And I can show you that if time permits. But like I was saying, with these dynamic graphs, you can actually just hover over the points and zoom into a given area of interest if you want to look at, say, this flood peak on November 15th in 1984. So that's those dynamic graphs I was referring to, and all of them are dynamic, so you can go through and view them a little bit differently. There's also a flood analysis method in here that is based on the USGS Bulletin 17B flood skewness method, which fits a logarithmic distribution of flow data, and then it plots not only the observed data but the interpolated data as well as confidence intervals around that for flooding, peak flow values out of the USGS, and then gives you a summary of recurrence intervals. So you can say, what is the 200-year flow here? Well, the 200-year flow here, according to the Bulletin 17B method, is a 14,000 CFS flow, plus or minus those confidence intervals, of course. The flow analysis tool also includes a drought analysis, which is a statistical regression of annual flow data and annualized total acre feet per year flow data relative to the average over time, or some sort of drought threshold that you specify in acre feet. And you can determine when you've had those periods of low flow. And then it fits a regressive model to it, forecasts it forward, and then comes up with this nice summary graph of the length of the drought versus the lambda, which is the color coding on this, is the magnitude of the drought versus the recurrence interval of the drought. The colors are, of course, the forecasted data, and the black line is the historic data. So, you know, for this particular one, I didn't pick a very good regression model because those lines don't exactly overlap. But you can go back to the interface and fine-tune the magnitude of that regression, the type of regression, or you can optimize it here. And that's the drought analysis. And it has that similar if you want to look into the interactive graphs versus just the static ones. One of the other features we have in the flow analysis tool is this base flow analysis, which basically does a filter regression to pull out base flow relative to stormwater stream flow, and highlight the difference between those two, as well as some statistics. This is all based on a tool by Arnold and Allen with the USDA out of Texas, A&M University. So it's got some statistic summaries about different base flow fractions depending on which filter paths you're using. And you can download those result data as well. One of the cool ones is the flow duration curve and the load duration curve analysis, which you can take a flow duration curve, which is basically a time series of flow data rearranged by magnitude and how frequently it happens. You can take that and multiply that against a water quality standard that you're interested in. Say I want to look at a 2 milligram per liter water quality standard at this site. This will combine the observed nutrient data for total nitrogen versus the flow data and the combination of the two, and it's going to spit out a summary graph of total acceptable load relative to flow magnitude and how frequently that happens, as well as where observed data lies on that entire plot, which is really helpful in going down the road towards the TMD analysis. Sorry, TMDL, my bad. And once that loads real quick, any questions so far on the flow analysis tool? So what it does is it will summarize those flows. These are the flows times the water quality target concentration that you set for a grand total of kilogram per day total nitrogen load in this river. And you can see for the given year, you've got that standard red line, and then you've got the total records, the red line, and then each individual year is plotted as the gray line, so you can start seeing some of the natural variability in these stream flow systems.
What's the red line again?
The red line is the total average for the entire flow record.
Okay.
And each individual gray line is a single year. And that's all explained up in some of these summary paragraphs under this further model info. So if you have any questions about any of these particular tools, you can hop in and read up on the flow duration curves, what they're doing, the load duration curves, what the seasonal is, how it tries to detect different pollutant sources based on where the observed data is greater than the desired curve, and other things like that. And then different management practices that are probably likely to help this. In this particular case, all this data on the load duration curves was developed based on recommendation guidelines from Bruce Cleland with the US EPA under his TMDL management approach. But all of the tools have this further model info button so that you can go in and see what's actually going on behind the scenes and what these tools actually are. But the red line is the total data, and the gray line is each individual year, and then the green dots are all the different are all the different nutrient concentration observations. So for a given observation, you can tell that these are certainly higher than that 2 milligram per liter standard that we set. And then the little black dots overlaid on top of that is a seasonal look at it. So under this advanced option, you can specify, do I want to look at the winter season? Do I want to look at the spring season? Is this a snowmelt dominated river? Is this more like a hurricane, tropical cyclone kind of dominated river? Or is it some sort of other trend? And you can look at the seasonal differences in those water quality points. And like I said, for any of these tabs, if you had any question on what the model is actually doing, you can just click that model info guide, and it's going to run you through exactly what's going on behind the scenes as far as those regression equations and how it fits everything, and then all the documentation on where this work came from. Same with the flood analysis tool. You can hop in there and you can see all the notes on the different Bolton 17B methods, as well as the original guiding document that the USGS came out with. Some of their frequently asked questions, and then one of the bigger things used in flood regression is the standardized flood skewness coefficient, which is complicated if you get into it, but we've pre-processed that all for you guys, which helps. And one of the last tools that we have floating around in here is the LOADES tool, which is a load estimator tool, which takes observed flow data, observed water quality data, and then interpolates between there so that you have a bigger record of water quality data. It's of course based on fitting a model to that data, but this was produced by the USGS, so they're pretty happy with the quality of that model. So you can sit down and look at water quality loads over time as far as kilograms per day for a given period of time, and then some statistics about it as well. You can also look at, say, the monthly averages of those loads over time versus the annual loads over time. Any other questions on the flow analysis tool at the moment? I guess the only other real thing that I'd like to highlight is one thing that I frequently use this tool for is I find this interface pretty straightforward to find a gauging station of interest, and you can also just hop over to a tab and say, I want to download flow data, download flow data. It'll download the actual USGS flow data, or if I only want the flood data, or if I want the nutrient data for that total nitrogen, it'll download that for me. Just based on what tab you're on, it'll download the right data for you. It'll also, there's also a link here that sends you out to the USGS data site itself for a summary of what that site is. So you can see their version of all the data and how that interface to act with extraction and that sort of stuff. And that's just this site info link. And if you're on a storage station, it'll take you to storage summary. If you're on a CDWR station, it'll take you to CDWR station. Well, if there aren't any questions on that, then I'm going to move over to the WRAP tool. Now, the WRAP tool is a watershed assessment tool at eRAMS.com/WRAP that was developed jointly with CDPHE and a Clean Nutrient Center project here at CSU to do watershed scale assessment of at-risk watersheds. So you can sit down and compare a dozen different watersheds at different scales. You can compare a HUC 8 to a HUC 12 and start getting an understanding of which one's more vulnerable to this, which one has this data, and which one's in those sort of violations. So again, you're on the standard eRAMS page. We're going to zoom into Fort Collins again. Once we're in Fort Collins, the first thing that you have to do with the WRAP tool is specify your area of interest, your watershed boundary. And you can do this in a dozen different ways. If you want to trace out that I'm interested in this particular section of Fort Collins over here, you can draw a polygon, and then it'll ask you to name it. Or I could sit down and say I just want to look at a rectangle, make it nice and simple. Or you can also analyze layers, GIS polygon layers that you've uploaded. But because I'm on the public side, I haven't uploaded any layers, but I could analyze an uploaded layer here. So if you knew that your area of interest was this particular watershed that's not really a HUC 12 and it's not really a HUC 10, but it's over here and I actually have the shapefile for it, you could hop over here to the map tab, upload that layer, and then choose it here. And if you could choose a single polygon inside of that shapefile, or you could choose the whole shapefile. You can also use a known boundary to examine data at a county level or a watershed scale level. So I'm going to do the watershed scale level and look at the city of Fort Collins, HUC 12 here in Fort Collins. So you notice it goes out and grabs the watershed boundary for that particular watershed. Any questions on how to select a watershed with the WRAP tool? Okay, once you have your area of interest selected, you hop over to the next thing, which is you select the data that you're interested in summarizing. And there's all sorts of data, and it's summarized by category. So we've got climate and snowpack data, we've got environmental data, we've got hydrology stream data, all the way down to land surface and some others like confined animal treatment locations. And if you ever are interested what these acronyms are, we've got little nice tooltips that explain that PRISM is the Parameter Elevation Regression on Independent Slope Model, which is a climate regression data set. And you can also follow this data info link that'll summarize this is what PRISM is, this is what it covers. It's the lower 48 states, as opposed to NOAA covers all of the United States, as opposed to SNOTEL here only covers just the western states, because there's no SNOTEL monitoring sites in the plains because there's no persistent snowpack there. And there's all sorts of links off it to their actual websites if you want to go look at the data directly from them. And that's available for each one of these different categories. So if you want to sit down and look at just the environmental data, or if you want to go down and look at the hydrography, or if you want to go all the way over to aquifer extent down in the groundwater section, we've got those summaries for all of the different data sources. But I'm going to go through and pick one of the climate monitoring data sets, this NOAA GHC&D, which is joint between NCDC and NOAA as far as climate monitoring sites. We also have stream discharge. We also have the EPA 303D impaired water bodies list pulled in here, as well as the water body classification codes as far as what is their classified use. Is it recreation? Is it public contact 1? Is it fishing? Is it all of those? We also have the Surgo soil data, so you can look at the different classifications, some of the classifications within that database as far as drainage class, how quickly those soils drain. The hydrologic group, that's really useful for watershed modeling as far as this, is this an A soil, is this a B soil, or the runoff potential. We also have the groundwater as well as some other land surface data sets, including impervious surface from the NLCD. So you can get a sense of what is the general imperviousness in this area that's preventing the runoff from infiltrating. Or if I want to look at land use, you can specify, you can look at a single year of land use, either from the USDA or from the USGS. Those are their two databases. You can look at a single year, or you can pick the trend one, which will compare multiple years next to each other to see how the land use has changed over time. You can also interact with U.S. Census data from 2000 to 2010. And you can also interact with some Reg 85 data that's Colorado specific, some confined animal feeding operations data, which unfortunately is not in this particular watershed, so I won't check that one. That's only Colorado specific. But again, all of these specify what the coverage is for these different layers at the moment. And once you've selected all the different data sources that you're interested in, you can hop over here to generate the report. And what it's going to do is it's going to open a brand new website and start loading up all the different data sources. Now, I've already run this just to save some time, but basically it gives you the title of what it is. It tells you what you analyze. This is the title of the area you analyzed. It gives you the area of that watershed that you're looking at, when you ran the report, and then it gives you a nice little table of contents for all the different data sources you included in there, as well as this quick one-off summary for indicators of watershed health. Those are just generalized indicators that at a glance you can look at a watershed and say, okay, it has 10% natural land cover, it has 80% natural land cover, the population is this, the density is this, just to get a general sense of how you can compare some of these watersheds to each other. So you can see over time with the natural land cover trends that back in 2008, there was more natural land cover. There was 76%. Today, there's only 65%. So in this particular watershed, over those years, we've lost 10% of the quote-unquote natural land cover. And then for each one of these data sections, you've got an interactive map that summarizes what the data is. So in this case, it's all the different NOAA, GHC, and D monitoring stations. And this is still an interactive graph. And you can zoom in and start looking at all the different names of all the different stations. And then it's got a time series of all of that data. One of the really new features that we just added in here is you can actually start downloading all this. You can get that data file. You can get that shape file of those monitoring locations. You can get that here in this data file, as well as a link out to the metadata that explains what PRISM is, what NOAA GHC&D is, and some of that stuff. That's more of like the ArcGIS style metadata. Any questions on that so far? Okay, so like I said, we've got the EPA 303D data. That's highlighted by the different subcatchments of the water body of the, I think these are WBID codes, as far as whether it's the main stem versus a tributary versus that tributary. And then it summarizes the impairments by that WBID. So, and tells you how many segments are inside of there. You can see that it's got a temperature impairment. You can tell that it has a copper impairment. And you can tell which reach codes are there. And it also has a link here out to the actual EPA database, their Attains water quality database, that houses all of this data. So you can get the summary here, or you can hop over here and get a real similar look. It's still temperature and mercury. And this is for each one of those different segments. So it's got a nice little list of all that stuff. And then the same thing for the water body classification code. So it's again summarized by the section of the watershed that it's in. And then it says whether it's agricultural, whether it's domestic, whether it's primary contact recreation, whether it's aquatic cold life versus aquatic warm life. And it's got that same summary and its same link out to the database. The next one that's up is we've got a soil summary. So you've got this nice little interactive summary of all the different soil classifications that are in there as far as their drainage types. So you can see that most of the soil in this particular watershed is well drained. There's some that's poorly drained and some very poorly drained. Of course, the little missing spots are typically water bodies that you don't have any soil data. No one sampled the soil underneath that reservoir. We've also got those imperviousness trends that I was telling you about. So you can sit down and look at, back in 2001, we had a roughly 7.1% imperviousness average for this entire watershed. So you can actually go down and see the imperviousness levels on a scale from 0 to 100 of what sort of level of impervious is there. Is it all concrete, or is it somewhat concrete, or is it roofs, or is it gravel kind of thing? That's what the imperviousness gets at. And you can see over time that that imperviousness has increased. That makes sense. The city's grown. They built more roads. They built more houses. There's just more imperviousness in the same location. And then you get a very similar summary with the land use that compares it over time, that you had that original 76% natural land cover all the way down to today's 65% natural land cover. And you can go in and examine all the different land use codes in here as far as if it's alfalfa or if it's urban developed open space or urban developed high intensity. And it also explains what's going on as far as how do we define natural space versus non-natural areas based on land cover. And again, you can download all of these maps as a nice little summary here if you want to have those rasters to interact with on your local computer for your local analysis. We also have the population data pulled from U.S. Census. So we've got the different blocks labeled out here, and it'll hover over and tell you the population density of those various blocks. And they're color-coded accordingly, and you can see the population growth over time between those two censuses. We're working to add the future estimated 2016 population as well as the 1990 and 1980 censuses. So we're working to expand this into more census data so you can get a more general estimate of decadal changes in the watershed over time. As I said, there's no CAFO information here. And then you also get a nice summary of the Reg 85 monitored wastewater treatment plants by the state. That's all stored in STORET data that are summarized by the facility. Say that again?
What's Reg 85, Tyler?
Reg 85 is the state of Colorado regulation that dictates how to monitor and enforce and what water quality standards are there for wastewater treatment plants.
Okay, thank you.
No, that's fine. That's a good question. So this pulls all of those Reg 85 monitored wastewater quality plant data as far as their actual discharge location, as far as their upstream, downstream monitoring locations, and summarizes it per facility based on their station ID, and this is their permit number, of course, with the state, and then what sort of treatment type they have at that facility and what sort of core process, and then what their average discharge is. So if you notice way back up at the top, one of the indicators of watershed health was the total wastewater plant discharge for this watershed. So we can tell that 14.96 million gallons per day comes from wastewater treatment plants on an annual average basis. So this is annual average flow of observed data. This is not their permitted. This isn't their maximum permitted number. This is the actual observed data. Over the years, the Box Elder Sanitation District has discharged roughly 2.5 million gallons per day on average in the recent past for 2015's data. That's pretty much the wrap tool as far as the report summary. This is all interactive, so some of these longer ones, like these with the EPA 305B classification codes, if you want to scroll through this a little bit better, you can collapse that statistic summary down there or re-expand it. You can access the metadata. You can download the shape files themselves. You can download the data themselves. All of the graphs that are in here are interactive to the point that you can also just straight download the CSV data for that graph. You can download the pie chart. You can download it as an image if you want to put it in a report, or you could print this entire report yourself. We can also store those reports by giving it a unique ID code and saving it in our database. We're open to discussing whether the 24 hours is sufficient for what people want to store it as, but we at least have the capacity to store these reports over time. That's pretty much my presentation on the flow analysis tool, basic overview of eRAMS, some of the data sources that are there. Was there interest in having me do a little bit of a quick run through on the low flow analysis that's inside of the CDPHE tool?
Any thoughts from our audience members? I think we have time, Tyler. If you might want to do that, that'd be
Okay.
awesome.
The CDPHE tool is another sub-project here in eRAMS that's accessible to CDPHE, which is the Colorado Department of Public Health and Environment. They've worked with us over the last few years to develop a couple of specific analysis tools that they were interested in. And they're all here, and again, it's the same eRAMS sort of framework. But the low flow one that I'm talking about is this low flow analysis one that pulls all the different USGS monitoring sites, and then you can search for it based on keyword, based on shape file, based on rectangle, or however you want to do it. And you can sit down and pick the station of interest. So if I want to look at the North Fork of the Republican River out there near the border of Colorado, I can analyze all the different low flow conditions. This is an approximation of the EPA D-Flow, the design flow tool that they have, that a lot of the different permitting processes for wastewater treatment plants have to go through this D-Flow algorithm to figure out what is your 7-day low flow, 10-year average low flow kind of thing. So we can calculate all of those based on these different data sets for if you want to use the extreme value design, if you want to use the biologically based low flow, if you want to look at the human health low flow, or if you want just the overall flow summary itself. I picked the all in the interface, so this will take a little sec, but it's going to summarize all those different low flows the way the D-Flow tool calculates it. And again, you can download the data here. You can look into what these algorithms are actually doing, and it'll link out to that documentation for D-Flow and a few other things. One of the other ones that we've got is, I mentioned earlier, and Teresa asked about Reg 85. Reg 85 is the state set up water quality monitoring program for the wastewater treatment plants. So we have an interface here specifically designed to pull those station locations and look at the data there as far as the phosphate discharge, as far as the nitrate discharge, as far as their upstream data versus downstream data. So we have a multi-site analysis tool that we put together for them.
So there is a question on the low flow tool, Tyler, of can we add data to that tool?
Yes. Yes, you can. It's got that same link right here, and it's going to tell you to format it real similarly. You're going to have to call it date/flow because, I mean, we're not doing water quality, right? So you can upload your own flow data here, and then you get those same merge options if you want to analyze only the uploaded data, if you want to merge it in with the public data, which is the USGS data, if you want to, and then how you want to merge it for duplicates. So if you have a date in your uploaded data and USGS has a date, do I want to use mine? Do I want to use theirs? Do you want to use the average? Do you want to use the maximum? So yes, you can upload your own data and use it here just the same way as the other one. I'm going to refresh this real quick because I don't know why it's not finishing. Bad example, right? So you can interact with this and get that summary. So the human health design flow for this particular site based on the available data is a 21 CFS human design health site. You can also look at the Reg 31 flow summary, and this is more gets into Regulation 31 is another CDPHE regulation for in-stream water quality. Well, in-stream water quality is typically dictated off of some sort of low flow, whether it's seasonal, whether it's statistical, whether it's so the Reg 31 flow summary was a customized flow summary that we put together for CDPHE. They also have a summary of different just access to STORET data, as well as the stream segmentation database. That one specifically looks at the water quality standards that CDPHE is planning to impose with the Reg 31 data, the Reg 31, Regulation 31. And we also have a fish monitoring site summary here that summarizes a number of different sites that the state monitors for mercury amounts in fish tissues for fishing advisories and health advisories. Any questions there, or maybe you want to see a demo of those, or?
So Tyler, these tools, were they on the resources page, or does someone have to know to type in CDPHE tools?
I do not believe that CDPHE tools is on the resources page.
Okay.
But these analyses are all capable. This particular low flow analysis is sitting on top of the same flow analysis tool infrastructure. So the flow analysis tool is pointing at the model that does all the analysis and fetching the data. This is pointing at the same one, and it's just turning on and off some different features in order to get these summaries.
Okay. So as far as if they have questions on like how to find these, because we've got some Colorado folks on the thing, and we'll be posting, hopefully we're recording this webinar and hopefully we'll be able to post it, but they can contact you as well, or?
You guys are welcome to contact me as well. I'm the primary developer that's written most of these analyses and the interfaces, so if you have any questions or clarifications, or you wake up tomorrow and you're like, well, I really wish I would have asked him that, feel free to email me. My email is, let me just put it on the screen for you guys real quick. So my email is just my name, tyler.weibel@collegestate.edu. You might get a reply from a slightly different address, but it all gets forwarded to the right one for me. So that's probably the easiest one to remember to contact me through.
Okay, thanks, Tyler.
And like I said, that Reg 31 summary basically goes through and does the 1E3 acute monthly low flow versus the 7E3 chronic versus the 30E3 chronic, and gives you that table summary of based on the different available data. So I hope that answers that low flow question. Sorry I couldn't get that first station I was looking at to work right. Any other sort of eRAMS questions or flow analysis questions, or how do I even log in and set up an account, or anything like that?
I'm not seeing any, and one of the things we are hoping to do is see if webinars like this help kind of explain how to use some of the eRAMS tools. So there'll be a survey after we finish the webinar to see if this helps and see if you have any other suggestions for how to really help kind of make sure these tools are usable. So we'll look for that feedback. Tyler,
and we're happy to go through and adjust these interfaces, adjust the tools, adjust the workflow so that it makes more sense from the user's perspective of how do I get from where I'm at now to this specific analysis. And if what we've set up doesn't make sense to get there, we are happy to discuss it with you guys about changing that. Well, I think we're probably going to let you guys go a little bit early. You can actually go get lunch or something.
And so there will be a survey coming to you, and we'll try to schedule this at a good time. We're thinking Friday mornings at this time every month, just to keep being available for how to use these tools. So feel free to email us or um, contact us and check out the eRAMS.com website for all the tools that are out there. So if there's no further questions, I think we can end our session today. Does that sound good?
Thank you for joining us. We really appreciate your participation. Let us know